To determine the weight of copper conductors such as 500 kcmil or 350 kcmil per linear foot, several resources are available. Firstly, consider electrical engineering handbooks and standards. One valuable standard is IEEE Standard 835-2021, which details test procedures for alternating current high-voltage circuit breakers rated on a symmetrical current basis. Additionally, ANSI/NEMA WC57 focuses on the calculation and measurement of winding temperatures in transformers, regulators, and reactors. Another essential resource is the National Electrical Code, NFPA 70 handbook. These handbooks provide comprehensive data and standards related to electrical conductors. Secondly, explore online resources. Southwire offers a copper conductor weight calculator at their website. Aconite provides a copper conductor weight table available as a PDF document. Belden also offers information on wire and cable copper conductor weights on their website. Furthermore, several online calculators, such as the copper wire weight calculator, can be helpful. Thirdly, refer directly to manufacturers' websites. General Cable, Prysmian Group, Nexans, and Southwire are all manufacturers that provide detailed specifications and data sheets for their copper conductors. It's important to note that the weight per linear foot can vary slightly. This variation depends on the manufacturer and the grade of copper used. For the most accurate information, always refer to the specific manufacturer's data. To elaborate on the use of the National Electrical Code, NFPA 70 handbook, this resource provides essential guidelines and requirements for electrical installations. It includes tables and information on conductor properties, including weight, ampacity, and insulation types. The NEC handbook is updated regularly to reflect the latest industry standards and safety practices. When using online calculators, ensure that you input the correct parameters such as the conductor size in kcmil and the desired length. These calculators typically provide an estimate of the weight based on standard copper densities. However, remember that these are estimates and the actual weight may vary. For manufacturer websites, navigate to the product catalog or technical specifications section. Look for the specific conductor size and type you are interested in. The datasheet should include the weight per unit length, typically expressed in pounds per foot or kilograms per meter. Some manufacturers also provide detailed information on the conductor's construction, including the number of strands and the insulation material, which can affect the overall weight. When considering different grades of copper, be aware that the purity and alloy composition can influence the density and weight. Electrolytic tough pitch copper is a common grade used in electrical conductors, known for its high conductivity. However, other alloys may be used for specific applications, such as high-strength or high-temperature conductors. These alloys may have slightly different densities than ETP copper. In addition to weight, other important factors to consider when selecting copper conductors include ampacity, voltage drop, and installation requirements. Ampacity refers to the current carrying capacity of the conductor, which is determined by its size, insulation type, and ambient temperature. Voltage drop is the reduction in voltage along the length of the conductor, which can affect the performance of electrical equipment. Installation requirements include factors such as bending radius, support spacing, and termination methods. When working with electrical conductors, always follow safe work practices and adhere to applicable electrical codes and standards. Wear appropriate personal protective equipment such as gloves and eye protection, and ensure that the power is disconnected before working on any electrical circuits. Consult with a qualified electrician or engineer if you have any questions or concerns. The Southwire Copper Conductor Weight Calculator is a useful tool for estimating the weight of copper conductors. It allows you to input the conductor's size in kcmil, the stranding class, and the desired length, and it will calculate the approximate weight. The calculator also provides information on the conductor's diameter and ampacity. The Aconite Copper Conductor Weight Table provides a comprehensive listing of conductor sizes and their corresponding weights. The table includes information on different insulation types and stranding configurations. It is a valuable resource for quickly determining the weight of commonly used copper conductors. Belden's website offers detailed information on their wire and cable products, including copper conductor weights. You can search for specific product numbers or browse their catalog to find the data you need. Belden also provides technical specifications and application notes to help you select the right conductor for your application. The copper wire weight calculator is a general-purpose tool that can be used to estimate the weight of various types of copper wire. It allows you to input the wire gauge, length, and density of copper, and it will calculate the approximate weight. This calculator can be useful for estimating the weight of small gauge wires or for comparing the weight of different wire types. Manufacturers' websites are the most reliable source of information on copper conductor weights. These websites provide detailed specifications and data sheets for their products, including weight per unit length, ampacity, voltage drop, and installation requirements. You can also find information on the conductor's construction, insulation type, and applicable standards. When using these resources, it's important to pay attention to the units of measurement. Weight is typically expressed in pounds per foot or kilograms per meter. Conductor size is typically expressed in kc mil, which stands for 1,000 circular mils. 1 circular mil is the area of a circle with a diameter of 1 mil, which is equal to 0.1 inches. The kc mil value represents the cross-sectional area of the conductor, which is directly related to its ampacity. To convert from kc mil to square inches, divide the kc mil value by 1000 and then multiply by pi/4. For example, a 500 kc mil conductor has a cross-sectional area of approximately 0.393 square inches. When selecting copper conductors, it's important to consider the application requirements, including the voltage, current, ambient temperature, and installation environment. The conductor must be sized appropriately to carry the required current without overheating or causing excessive voltage drop. The insulation type must be suitable for the operating voltage and environmental conditions. The installation must comply with applicable electrical codes and standards. In addition to copper, other materials are sometimes used for electrical conductors, such as aluminum. Aluminum is lighter than copper but has lower conductivity. Aluminum conductors are typically used for high-voltage transmission lines and some building wiring applications. When using aluminum conductors, it's important to use appropriate connectors and installation techniques to prevent corrosion and ensure a reliable connection. The NEC provides specific requirements for the installation of aluminum conductors. Understanding conductor properties such as weight, ampacity, and voltage drop is crucial for designing and installing safe and efficient electrical systems. By utilizing the resources mentioned above, you can obtain accurate data and make informed decisions when selecting copper conductors for your specific application. Remember to always consult with a qualified electrician or engineer if you have any questions or concerns. They can help you select the right conductor size and type and ensure that the installation complies with applicable electrical codes and standards. Furthermore, consider factors such as skin effect and proximity effect when dealing with alternating current conductors, especially at higher frequencies. These effects can cause the current to concentrate near the surface of the conductor, effectively reducing its cross-sectional area and increasing its resistance. The NEC provides guidance on directing conductors to account for these effects. Also, be aware of the potential for corrosion when using copper conductors in certain environments. Corrosion can increase the resistance of the conductor and lead to premature failure. To prevent corrosion, use appropriate connectors and coatings and avoid exposing the conductor to corrosive substances. The NEC provides specific requirements for protecting conductors from corrosion. In summary, determining the weight of copper conductors requires a multifaceted approach involving consulting electrical engineering handbooks, utilizing online resources such as calculators and manufacturer websites, and understanding the specific properties of the copper grade being used. By carefully considering these factors, you can ensure the selection of appropriate conductors for your electrical applications.